Hello, my name is Matthew, and this is my Ca2 DoublyLinkedList assignment for data structure in gaming. First off, we'll be looking at the code in part 1 and part 2 of the video. In part 3, we'll be looking at the testing and the feedback I got. Okay, let's go on and look at the timer class. First off, we added a timer header file. We would take in a class of private and public. These are all the methods that I'll be using, and these are private that are seen inside the class and not anywhere else. In timer CPP, we then add function to these classes. So we have the getters here, and data stamp with create a year by month by day structure. We have a constructor, we have a reset function, we reset everything, and then we have some getters that return the times and all that. Now we move on to the player class. First off, we have the player header, which have string first name, last name, experience, and level private that only can be seen by the class itself. It have function constructors, deconstructor, getters, and setters, and also a print method. Okay, in the player class we had our constructor. This method is used to add value to the private thing. We have a full constructor. We have a destructor which does nothing. And getters, we have get first name, get last name, get level, get XP. These methods are used to return value of the player. It takes no argument and return an int or a string depending on which one you're looking at. The complexity is OC or 0C. Then we have the setters with set first name, set last name, set level, set XP. These methods are used to change the value in the player class. It return nothing, and it take an argument of string and int, and then 0C is the complexity. And then finally the print, which is print out the player. It take a non argument or no return, and 0C. Okay, now we're moving on to the data linked list. A double linked list, sorry. First off, we shall look at the top, and this is a custom linked list which have a dlist node with model node, the linked list with model list, and dlist iterator with iterate through the list. We include the player.h. We forward class declare everything, as the compiler would, if we did not have it, the compiler would get confused and say, hang on, message from this class, need message from this class, but this class hasn't been made yet. Okay, now we move on to the class dlist node. We add data type value, a dlist node value of next would get the previous node, or get the next node, and the previous get the previous node. We have a couple of deconstructor, basic, none, one that passes in data type, and the one that passes in a data type previous pointer and next pointer. We have a dlist node which does nothing. Getters, we have getter next node and prev node, and the plus not supposed to be that. These are used to return the previous or the next node. It takes in no argument and return a dlist node data type. We have setters that set next, set previous. These are used to set the next and previous node to a new value. These are mainly used in the insert function, while the getters are used in the remove function. Now we have the dlinked node or DoublyLinkedList, or dlinked sorry, which have an mhead, which is the start, mtail, which is the end, iterator, and a count. First off, we create a constructor, a deconstructor, which is it would save the pointer to the next node and then delete the current pointer and make the next pointer, the next node, the new node. Append. This is used to add element to the end of the list. The argument is taking a data type, it returns zero, it return nothing, and have a complexity of 0c. If the list is empty, then this means that there's nothing in there, so m head and m tail are going to equal to a new node. So pretty much, if the list is 0, then it add 1, and since m head and m tail are pretty much there's only one, then it can be both. Else it will go and add the new element to the back and reset and update. So it will add on if element have been added. Prepend add a new element to the start of the list. Its data type, its argument is data type. Its complexity is 0c. Again, if there's only one, if there's no element into the thing, it will do this. Else, it will create a thing and set it at the head of the um, list, and then count again. Is empty is used to check if the list is empty or not. It return a boolean value. It have no argument, and I found this on the website here, which I give a link to. The complexity is 0c. So if head is equal to nothing and m tail is equal to no pointer, then return true, else return false, and move on to insert it. Iterator position, and these are iterator begin, iterator end. These functions are used to search in the search and print method, which is used in the player database class. And type node is used to tell the user or tell the compiler that everything is okay and move on. It returns the iterator of the moving node. Complexity is 0c. Insert. This is a function which inserts the value that correspond to the player want the position to be in. I got help from by Lucas for this one. See, I had multiple insert thing. He said you can fix it down all to one, so I have yeah. The argument is taking an integer position and data type. It return none, and overall the complexity is 0c, but become 0n while when looking for the position. So again, if is equal to 0, then make that and add to the counter. If it's less than or equal to 0, we prepend for because my teacher want that. If it's greater than or equal to m count, then we append, which put it at the end. Else it will put it into the position that you wanted to go into and then count. The return is just there to so it just exit after that and exit after that. Remove function. Pretty much the same as insert but the opposite. So when Lucas helped me do this, I was able to move on and do the remove function by myself. And the function is used to remove information from the position that is asked. And it taking an argument of the in position. If return nothing, overall is order C and become order N when looking for the position. Again, if it's empty, then the list is empty. Else, invalid number, because we can't do what we have done in the. It can't be less than 0. Like we can't do what we have in the insert. If it's equal to 0, then remove the head. If it's equal to the size of the list, then remove the tail. If it's equal to 1, delete the head. If the size of the list is equal to 1, then that means both m head and m tail should be deleted. Else it should remove the element from the position that you asked and then minus the size. Okay, remove head. This removes the head of the list. Take in no argument and return none and have a complexity of order C. Uh, Again, if the m count is equal 1, delete head and tail, and head and tail make both null pointers. Else, just delete it and minus the counter. Name remove tail. Remove the tail of the list, and it have an order complexity, and it's pretty much the same, but opposite. It's just delete the last element. The size. This function is used for for some in the menu. It return the count, which is the size of the linked list. It have no argument and return uh, count but minus 1, and the complexity is 0z. Okay, in the next video we'll be looking at the iterator and the player data base class and display menu, and then finally for the third video we'll move on to testing and feedback, and we'll be looking at the final function, which is the main class. I hope you thanks for watching, and I hope you enjoy these videos so far. Thank you.